I know. How'd you distract me? All right, there are 2 new topics in this unit and plus one kind of reviewy topic because the last topic we do is conic sections, which maybe you guys have seen before. That's mostly for Calc 3 that we do this. But today we're talking about polar coordinates. This is a different graphing system than the rectangular graphing system, or called the Cartesian system. And the basic premise in this system is that you start at a point called the origin, and you graph points in the plane using an angle and a distance away from that origin. So you say, okay, I want to be at an angle of pi quarters and a distance of 1 away, and that gives you this point. Do you see how that could work? I want to be at an angle at pi halves, a distance of 2 away gets you that point. So it's an angle and a distance. And that's called a polar coordinate. So you fix a point O called the pole, which corresponds to like 0, 0 in the regular system, the origin. And then you construct a ray called the polar axis. So there's your pole, here's your polar axis kind of is like the positive half of the x-axis. And each point P is assigned coordinates r theta as follows. So r is the directed distance from O to P. So if I have my point P there, r is how far away, like as in, away is out. If my point was down here, away would be down. Yeah, r is distance. And then theta is the angle, measured the normal way that angles are, counterclockwise, right? Yes? Okay. And so theta is that directed angle counterclockwise from the polar axis to that segment. So that's the basic idea of what a polar point is. Okay, it's a distance and so r theta, it's a distance away from the origin and an angle. Let's graph some points. And on these grids that I gave you, and if you have a Mac, the graphing program on the Mac called Grapher does graph in polar coordinates. You've got to select that. And I think there probably are online polar graphers too you can use to get a feel for how these things work.
Just setting on your calculator.
Okay, yeah. But notice how these points that I'm highlighting right there, those are all a distance of 1 away from the origin. The next circle out are all the points that are a distance of 2 away, right? And the next ones are a distance of 3 away, right? Does that make sense? So if you're going to plot the point 3, 3 pi quarters, you're a distance of 3 away from this origin. And what angle are you at? 3 pi over 4. So you've gone from there over to that point right there. Do you buy that? Does that make sense? Okay, and I will give you grids to draw on because it makes things a heck of a lot easier. Okay, how about 2 and 3 pi? So first you're a distance of 2 away, right? And then you go an angle of 3 pi, which is the whole way around the unit circle, and then what? And then halfway, which spits you out at this point, right? Does it make sense? I also could have written that point as 2, pi. Yeah? So that's one thing that's different about polar coordinates versus Cartesian coordinates. Polar coordinates are not unique, meaning there's more than one way to write a point. Whereas Cartesian coordinates, if I give you 1, 1, that's the only point that's over 1, up 1, right? So there are many ways to represent one point. And by many, I should actually say there's an infinite number of ways, right? Because you could keep adding 2 pi, right, repeatedly? Yes.
If you go, if you say negative pi, would that be the same way?
Yeah.
You go backwards.
Yeah, you can also go backwards. 2 negative pi is the same thing. Yep.
Yep.
Yeah, it's going to be fun. Actually, the really fun thing is when you have negative radii. Okay, this is
Flips it over.
Yeah, so this, you see how this is negative 4? So what the heck does a distance of negative 4 mean? How does that work?
It's for the opposite direction.
Yeah, it makes it go the other way, but some of you guys have seen this before and some of you haven't. So for those that haven't, here's how this works. You plot the point 4, negative 5 pi over 6, and then you reflect to get negative 4, negative 5 pi over 6. Okay, and I know this is weird and I hate it too. But if I was plotting 4, -5 pi 6, that ends up right out here. Does that make sense? And then you look at the sort of diagonal that it's on, and you rotate that 180 degrees to do the flipping or the negative r thing. So that puts this point in the end right there. Does that make sense? An easier way to represent that point would have been to call it 4 and then what angle? Pi 6. I do know some pre-calc, I think some of you that are pre-calc classes taught you this stuff, right? Yeah, exactly. So the negative radii by far is the trickiest part. The negative angle just means you go clockwise as opposed to counterclockwise. That's not hard.
But if it's negative, don't you just go in the other direction?
If the angle is negative, yes, you go in the opposite direction. Yes.
Why can't you just go back like to the left 4 where it's -4? And then just go -5 pi 6.
That is not how it's defined. I have to think about that. I'm
trying to think of a scenario where doing that would ever give you a different answer.
does it give you a different answer?
It's like, no, it gives you the exact same.
Oh, that's right. Okay, yeah, because, yeah, you just do the rotation first. That's okay. But because you go -5 pi 6 from that point, right?
Yeah.
Yeah, that's gonna work.
Okay.
Yep. Do you guys understand what he meant? So, here we go. Is the polar representation of a point unique? We already discussed the fact that it's not. So graph the following points. Where would 2 pi quarters land? In what quadrant?
First.
First, a distance of 2 away. Oops, that's actually wrong. On the middle one, right? Okay. How about -2 5 pi quarters? So I'm just I'm gonna do it the way that more common. I'm gonna plot 2 5 pi quarters, and then I'm going to reflect. So that puts us over here, right? No, it puts, oh, okay, I was just testing you. That puts us
Down quadrant 3, right?
down right there, and then the reflecting throws you back up to the same spot, right? So there's your, it would probably be helpful in your quiz when you're plotting these points if you have to show your work, like have your final answer in a different color, or just label it really obviously.
Can I just use an open circle for my work and a closed circle?
And then
for my
just give a key to what your system means, okay?
All right.
-2, -3 pi quarters. Well, that throws us backwards to here, right? And then reflects it up. So those are all 3 different ways to represent the same point. Could you give me one more with a +2? -7 pi over 4 would be right. Negative pi over 4 won't do it because negative pi over 4 just puts you down there.
No, I
What were you saying?
said 9 pi.
Oh, that's right. Yep. Do you guys agree that -2 or +2 mod +9 pi over 4? That's the same thing, that's just going the whole way around plus a quarter again? Okay. You buy it? Yes?
Should I be writing this down on a quiz? This is how I got this point.
This was just to point out that these things are like, you can make different ones up, right?
Yeah.
Yeah, okay. So is the polar representation of a point unique? Gosh, heck no. Unique means is there only one way to write that point in polar curves? No, not unique. It has lots of twins.
We're going to go over the unique points. Are we going to go over unique points later in the lesson?
No. Polar points are never unique.
Oh, they aren't?
Yeah. So here's an example. A unique representation is like the point 1, 1 in x, y coordinates. There's only one way to write 1, 1. Does that make sense? Like the point over 1 up 1, that's the only way to write that point. It's a unique representation. If you have a different x or different y, you get a different point, right? But with polar curves, there's more than one way. One way to write one point. So you're unique if there's only one way to express you. You're not unique if there's more than one way to express you. And so you see how all these expressions gave the same point, right?
Yeah.
So the polar representation is not unique, it's not special. If you know one way to write a point, you can also generate lots of other ways to write that point. Does that help?
Yeah, makes
Okay.
sense.
Okay, great. All right, so since we're graphing points, it would make a heck of a lot of sense to figure out how to convert between these two systems, right? Okay, so here are the conversion formulas from polar to rectangular. X is our cosine theta, Y is our sine theta, and I made a typo, tangent of theta. This is going polar to rectangular. And this guy, that should say Y over X. And I'll be able to explain why there's a little triangle we can draw.
And sine cosine polar.
Sine cosine.
Say that again? Yeah, this is taking rectangular into polar. Okay. So suppose we have a point that's R theta. It could be in any quadrant, but we'll just say it's in that first quadrant for simplicity. Okay, if I was to graph that in regular coordinates, I would graph how far X is and how far Y is, right? Does that make sense? Now, using right triangle trigonometry, this is the angle theta, right? What is sine of theta? What is cosine of theta? Just with that right triangle. And what is the hypotenuse of said triangle? R. So sine is so opposite over hypotenuse. And doesn't this give you that formula? This is X over R, right? And then multiplying by R gives you the other formula. Do you buy that? Okay. Tangent of theta, do you now buy that that's equal to Y over X from the right triangle? Yes? And then, do you see where this thing comes from? R squared equals X squared plus Y squared? Just Pythagorean theorem, right? Okay. So that's how you convert back and forth. And in the case of a unit circle, your R is 1, right? X is 1 cosine theta, Y is 1 sine theta. Yeah? Okay. So let's convert these points from polar back to Cartesian. So X equals R cosine theta, Y is R sine theta.
So that's 2 times cosine of pi over 6.
Mm-hmm. I'm sorry, but you do have to know trig. Cosine of pi 6.
1/2.
Square root of 3 over 2.
Root 3 over 2. That unit circle just will not let you forget it. X is root 3. And then Y is 2 sine of pi 6, so it's sine of pi 6.
That's a half.
That's a half. So the Y is equal to 1. This is the point. Square root 3, 1. Okay. How about 1 negative 3 pi quarters?
That's a negative root 2 over 2.
Yeah, I think so. So the X is negative root 2 over 2. And the Y is 1 sine of negative 3 pi quarters, which is,
Negative root 2 over 2.
aren't those the coordinates given on your unit circle? Do you see what I mean? And that's because of the fact that this was radius 1. Does that make sense? Okay.
So does that mean that polar coordinates do each associate with a unique Cartesian coordinate? So they're not unique on the polar scale, but they'll be unique on the Cartesian?
Every polar coordinate gives only one Cartesian representation, but that means that the Cartesian thing is unique, not the polar. Does that make sense?
It's a good identical.
Because you could have different polars that give the same Cartesian. I could have also given you 1 comma 5 pi quarters as your original point, and that would have given the same answer. So it's the this thing that's unique, not the r theta thing. Yep. Okay. And I don't know, I find, okay, So convert the following points into polar coordinates. So first of all, I think it's a good idea to sketch where this thing is, because a lot of times from the sketch, you can actually guess what the angle is supposed to be and stuff like that. We can verify using the formulas. So you plot 1, -1, that's backwards 1 and down 1, right? That's the Cartesian thing.
Looks like,
Okay, so we know x squared plus y squared is r squared, right?
5 pi over 4?
Yeah, it is, and we can verify that using the formulas, okay? But do you guys agree that this, also, we have a right triangle, don't we? And in that right triangle, isn't this side 1 and that side 1? So what should the hypotenuse be? Root 2, right? Because we would, and we do, this works too, -1 squared plus -1 squared equals r squared, right? So technically r could equal positive or negative root 2, either one's okay, right? They're both legit answers. X squared plus y squared equals 1, -1 squared, equals r squared, sorry. So 2 is r squared. R is either 2, positive root 2, or negative root 2. Okay. And then the other formula was that tangent of theta was equal to y over x, right? So tan of theta equals -1 over -1, which is 1. Now that happens at many different angles of theta, right? And some of those angles of theta lie up here, and some of them lie down there. You've got to figure out which one to use. And because your point lands in quadrant 3, the theta that makes that happen, at least the sort of most common one, would be 5 pi over 4. Does that make sense? So our representation of this point would be root 2, 5 pi over 4.
And she also just inverse tangent it.
Oh, inverse tangent's only going to give you pi quarters. Right, remember that? So you have to actually think about solving this equation, what quadrant should my answer be in? Let me do one thing, then you can ask questions, okay? The one other thing is, what if you use negative root 2? Then what would your angle have been? Pi over 4. Do you buy that? Okay. Did you, that's what you're going to ask? Okay.
So, just in that case, just choose one and whichever one is.
Usually on your homework, what I'll ask you to do is I'll ask you to do one that gives me a positive r, and then another one that's the same point that gives me a negative r.
Okay.
Just to get the, idea of how this works. Yes?
So how come how did it change from positive root 2 to 5 pi over 4 to negative root 2 to 5 over 4?
Because of how you graph points that have this negative r. If you're graphing a point that has a negative r, you go over that angle, like there, and then you reflect. That's what the negative does. The negative part in the r does the reflecting. Oh man, 0, 3. This one you can do without having to use those formulas. You go over nothing and up 3, right? So what distance is your r? 3. What angle is your theta? Pi over 2. So one point is positive 3, positive pi over 2. What's a point with a negative r? Like how would I? Negative 3, negative pi over 2. Because to graph that point, you would go backwards pi halves and then reflect up, right? Or using a positive. Watch out for those restrictions. Like WebAssign might say that your thetas that you give must be between 0 and 2 pi, in which case it would actually count this wrong. Does that make sense? Just because otherwise there's an infinite number of answers it has to check, and that probably doesn't work for computer programs. Yes?
If you did plug it in or whatever, wouldn't it just give you undefined for maybe tangent of 3 over 0? 3 over 0 is infinity, and the inverse tangent of infinity is pi over 2, I think.
Okay, so so if you have tangent of theta equals 3 over 0, that's tangent of theta equals infinity, and you can't really inverse tan infinity, so these you really have to actually, I think it's really smart just to investigate them by graphing. For most of these points that I will give you, you could figure this out just by looking at where your point lands. You don't actually have to do any of this formula conversion stuff. Do you see what I'm saying? Okay.
Do all three of those points work? I don't know. Do all three of those points work? The -3?
Oh, yeah, they all give the same thing. To plot -3 pi halves, you go backwards pi halves, and then you reflect, that puts you back at 0, 3. To plot this one, you go forwards 3 pi halves and reflect. Yeah, they all work. It's just that sometimes WebAssign will say, keep your theta between this range of things. Yeah, but they all give the same thing. Okay. So sketch the region that satisfies the given conditions. So I have positive radii, and my theta is between pi quarters and 3 pi quarters. This is an appropriate Thanksgiving question, because it's going to look like a chunk of pie. Yeah? So if your theta is in between pi quarters and 3 pi quarters, that means you're in between this ray and this ray, right? And if you have positive r's, it means you're just going out from there without any reflecting. Does that make sense?
Shade that in.
So you have to shade that in, yep.
No, when I was in kindergarten, I wasn't good at coloring in the lines.
I'm not gonna judge you on your art, as long as you withhold the same judgment from me. There we go. Oh, slightly tricky thing. What if they hadn't had this restriction?
You should do a dash line.
No, it's not even that. What if they just said nothing about your R being positive, but your thetas being between? You could have also, yeah, so let me just shrink that marker a little bit. If R was less than 0 also, you would have had this region too. As in, like, not even dotted, like as in it would have been shaded in as well. Does that make sense why? Because you would plot, you'd go over some specific angle, right? And then you would reflect down into that as well.
If it was just R is greater than 0. With the sign,
If it
you're
was
also
just
along
R is
the-
bigger than 0, then I think actually there'd just be an open circle right there.
But it would be dash lines if the equals weren't in the.
Yep, it'd be dashed lines if there were no or equal tos on that theta restriction. Does that make sense? But if you just had R bigger than 0 only, that just means that this one little point right there, the origin or the pole, isn't included. Does that make sense? Because everything else is a positive R, right? Your R is only 0 if you're at the origin. Otherwise, your R is never 0, right? Okay. R between 1 and 3, and theta between pi and 2 pi. So I think that's, oops, there's R equals 1. There's R equals 3. And I think this is like a bundt cake. Am I making you guys hungry yet? Yes, I'm so sorry. Okay, there's your region. Or half of a donut. Sorry. Okay, go home, eat donuts. Not too many, though.
Not all.
Not all of you run marathons. And I don't eat donuts, so I've done it for years. Okay, identify the curve by finding our Cartesian equation for the curve. So, oh, weirdness. Okay. So 2 secant of theta, you're like, holy moly, that must be like the weirdest curve, most horrible thing ever, right? At least you kind of think that? Okay, or maybe not. So I would suggest, since all of your conversion formulas involve sine and cosine, change the secants, the tangents, the cosecants, all into sines and cosines. So secant is what over what? So this is 2 times 1 over cosine, by that. So r cosine theta equals 2, also by that. And what is r cosine theta equal to? Uh-huh.
So it's just a straight line.
Uh-huh, it's a vertical line.
Whoa.
I know, right? Isn't that weird?
That,
So, I mean, like, you could verify that if you go to like a polar graphing thing and you type in r equals 2 over cosine theta, it gives you a vertical line. How do you think you get horizontal lines?
That's really cool.
yeah, with theta equals.
Nope. With r equals 2 cosecant. Does that make sense? That's going to give you r equals 2 over sine theta, right? Which will give you r sine theta is 2, or y equals 2, which is a horizontal line. Yeah.
Why did they not think to just keep like the little prequel thing the same, like cosecant going for cosine instead of sine?
Oh gosh, I don't know. I don't know enough math history to answer that question. Yeah.
So, why didn't they, find, like, how would you not find y? How would you know it's just a vertical line, not find y first? Like, put, r squared equals s squared plus y squared,
Mm-hmm.
and put, so it'd be 4 secant squared equals 4 plus y squared.
That might eventually get you the right answer. I don't think it's the easiest way. As in, I don't think it's the easiest thing to always plug this into. You're going to be given easy equations to work with, and often just fussing with them and trying to get r cosine theta or r sine theta out somehow will be better than trying to just plug stuff in and go. I mean, you could also plug this in. I don't know where that's going to go from there. You'd have, oh God, no, yeah, oh, let's not. I think that, I don't know how to make that work, okay. What would theta equals pi thirds look like if you graphed it in polar coordinates?
No, it's not. That's right.
All the points that are the same angle, but any radius. Does that make sense? So any r, theta is pi over 3. So for positive r's, it's pretty obvious that it's this line. Does that make sense? So that first thing is for r's that are bigger than or equal to 0. And the question is, what happens if r is negative? So what if you have a point that's something like negative r pi over 3?
It's just the opposite, isn't it?
Yeah, you go over pi over 3, then you reflect down there. So you do get this straight line, right? So this is a line. And specifically, what is it through? What's the one point you know? 0, 0. Yep, the origin's the easy point, right? Can you find m?
Yeah. Just find one of the points and slope.
Just find one of the points. And actually, since your angle is pi over 3, if your r is equal to 1, how far over do you go? How far up do you go? You go over a half, right?
The root represents
Uh-huh, where does that come from?
cosine.
Uh-huh, cosine of pi thirds, and the other one's from sine of pi thirds, right? So your slope would be rise over run, which is root 3 over 2 over 1/2, or just root 3. So the equation of that is y equals just root 3x, because the, y minus 0, x minus 0 is just y and x respectively. So most of those you're able to get, I would focus on sketching pictures and just trying to, you don't want to work with the formulas like a super ton. Okay, how about this? R equals 5. Yeah, did you buy that? This is all the points that are a distance of 5 away from the origin, right?
Oh.
Right? That's what it means to be r equals 5. R equals 5 at any angle. Or you could say r squared is 25, right? Which is then x squared plus y squared is 25. So a circle,
5 at any rate.
center 0, 0. What's its radius? 5.
That's a Cartesian equation.
It is, yep. So identify the curve of finding a Cartesian equation. That curve is a circle of radius 5 centered at the origin.
You don't have to set it to y equals, do you?
No, that it'll also only give you the top half or the bottom half, so no, don't. All right, tangent theta, secant theta. Well, I don't know what to do. So, r equals tangent theta. Can I change that back into y's and x's pretty easily? think that one's just y over x, right? And secant theta is 1 over cosine.
So that's 1 over x.
So this is r cosine theta equals y over x, right? Or x equals y over x, and you had it, y equals x squared.
How did you go from r cosine theta to just x?
How did I go? Oh, because that's the conversion equation. X is r cosine theta, y is r sine theta. Kind of like how in the unit circle, x is your cosine, y is your sine, right? And that's a common trick you're going to have to use to convert these things back into rectangular equations.
All right.